highlight part 2 on chapter 16 about the amine. Now we're going to look at here a very specific NH2 functional group. This is called the amino group. We're going to study them deeper when we talk about protein. This is the building block of protein. And what I want you to look at here is to recognize you have a carboxylic acid group, COOH. We're going to study those later. A side chain R, and then you have the H2N or NH2, which is characteristic of an amino acid. Example, how can you write here the structure of N, N diethyl butylamine? Also be able to identify if it's a primary, secondary, or tertiary amine. You could tell that right away. So how do you look at that? Well, look at the name compound, and just it will give you the clues about the parent compound as well as its substituent. So here we use butyl. You do know butyl means 4. But is going to be that you have 4 carbon atoms. Then you have amine, so you know you're going to have a nitrogen atom attached to it. So 4-carbon alkyl amine is the parent compound. N, N tells you that you have 2 other groups that we actually call alkyl that are bonded to that amino nitrogen. And diethyl tells you that both of those are ethyl with 2 carbon atom groups. So when I want to write this down, well, I see that I have 3 alkyl groups that are bonded to the nitrogen atom. 3 to the nitrogen atom that has only 3 covalent bonds. I do know right away it's a tertiary amine. And I look at here, CH3, CH2, 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 N, so that's 4 but, and then 2 times CH2, CH3, 2 times ethyl, diethyl. Other example, here when you have that kind of compound, is it a primary, secondary, or tertiary? I could tell you right away when you see the nitrogen that is linked to 2 alkyl and it has 1 nitrogen present, knowing it has 3 covalent bonds, that can only be what type? Primary, secondary, or tertiary? That would be a secondary. Then I'm going to look at how many groups are attached to the nitrogen. So right here, I have a cyclohexyl on the far left. Cyclohexyl because I have 6 carbon atoms and it's an alkyl, so in cyclohexyl. That's the largest alkyl group that is bonded to my nitrogen. So that will be a cyclohexylamine. Then I see also a 1-carbon methyl that is also bonded to the nitrogen, and we have to put that N as the prefix. So when I look at here the name, it's a N-methyl cyclohexylamine. Because I have 2 groups bonded to nitrogen and only 1 hydrogen, I can tell right away that's a secondary amine. Something you have to look into also is the ammonium ion, where it's a positive ion formed by addition of hydrogen to an amine. So if you look at this, 3 different examples, I want you to focus on the H2O, the water molecule. One of the hydrogen is going to add itself to the NH2, make it NH3 plus, and because you're removing an hydrogen from that water molecule, you have the hydroxyl OH minus characteristic. Other example right here, ammonium ion are formed when you have amine that react with hydronium ion, which is H3O plus. In that case, same thing, I'm going to add 1 hydrogen to the NH2 that becomes NH3 plus, and then only have water as the second part instead of the hydronium ion. Things that you also need to know here, ammonium salts, it's an ionic compound that is composed of an ammonium cation, positive sign, and an anion, negative sign. That's what we call amine salts. They are most of the time odorless, white crystalline solids, much more soluble than neutral amine. And how do we name them? We combine the ion names. An example right here, NH4Cl, Cl is chloride, NH4 ammonium. So you have here some example at the bottom. I'm not going to ask you to name most of the ammonium salts, but understand how they can be formed. Why? Because they are important in medicinal chemistry. Many times we actually write them and name them by combining the structures and the name of the amine and the acid used to form the salt. Just example right here, methyl ammonium chloride is written as CH3 for methyl, ammonium HCl chloride, and we call those methylamine hydrochloride. I won't have to question about that, but you should still review it. And then finally, talking about free amine that is needed, where you can actually make them by treating them with a base. Strong base anyway, NaOH, sodium hydroxide, is going to be the one that gives you here NaCl, which is salt, water, and then you have that compound CH3NH2 in aqueous solution. Those are things we have. Quaternary ammonium ions have 4 organic groups bonded to the nitrogen atom, and that gives there a positive charge to the nitrogen atom. When you have no more hydrogen atom and no lone pair, ammonium ions are neither acidic or basic, and their structure in the solution will be not affected by change in pH from acidic to basic. We call those quaternary ammonium salts. Those are examples here. Well, why do I bring this up? Because benzalkonium chlorides have antimicrobial and detergent properties. We can use them for surgical scrubs and also sterile storage of some of the instruments. I will not ask you to be able to write how they are made, but just know the common feature, for instance, of benzalkonium chloride. I think it's important for you.